Hey everyone, we're back with another episode of I Build at 4 a.m. It's a beautiful day here in Lisbon. I hope it's a beautiful day to you as well. And I'm very happy because today I have two illustrious guests, Cláudio Silva and Guilherme Dantas, who are not only crazy good people, but created and take care of Bugbuster, the application, which is one of my favorite applications on the Cartesi ecosystem for being a flagship project. So, how are you guys?
Hello, hello.
Hey, Joao. Doing good. Thank you for the words.
This is very nice. I'm really happy you guys accepted this invitation. And I think it's nice for a little introduction to our spectators to get an understanding of what is Bugbuster.
Okay.
So Bugbuster is a trustless bug bounty platform in which developers can describe what constitutes a valid exploit to their programs, which we call an assertion script. And typically, this assertion script runs the program, which is developed by the developer. Then it runs the exploit that's submitted by the hacker. And then it finally checks if this program is in a valid state, like it checks the invariance of the program. And they can be sponsored in any ERC20 token chosen by the developer. And once they're submitted, the code cannot be changed, right, by the developer. And so hackers don't need to trust the developers in order to achieve the reward, right? So it really solves a problem in the industry of bug bounty programs. Yeah.
So it's like the reward is already there. It's deposited and waiting for someone to find the exploit for them to gain it, right?
Exactly.
Oh, this is so nice.
There is one aspect that Guilherme mentioned, and it's very important to highlight that a natural question when we talk about Bugbuster is why another bug bounty platform, right? Bug bounty focus in a very specific problem that we want to solve. That is the intermediation problem, right? Normally, the very well-known bug bounty platforms, they have this model where people submit not exclusively code to hack. They typically submit reports written in natural language. And then someone evaluates that to check if it really describes a bug, checks about the criticality of that report. And there is some subjective analysis. And this stage sometimes makes some discussion needed to find some agreement about if it's a bug or not, about the criticality. And sometimes this take times, didn't reach consensus, and then the platform needs to enter on stage also to mediate until an agreement. So the main idea of Bugbuster is to lock the reward, and there is a code that will evaluate if the exploit is valid or not. If it's valid, defined by code, the reward is unlocked, and then no intermediation. So this is our main focus to solve on this domain.
It's not something where you find where you list expecting a specific bug to appear, right? You just have all the assertions of the program as long as they explode somehow, then you're sure you found a bug. It's very, very objective in this sense.
Yeah. It's challenging, but also it's very objective and can make it very straightforward.
Yeah, I love the approach. Tackles lots of problems in bug bounties in general.
And one main aspect is that it motivates developers to start thinking on tests all the time, right? Which is very important for security.
Yeah. Test-driven development is probably the best way of developing. At least I think so. As long as you have time for it, do it. So Bugbuster was born during the experiment week, right? Cartesi's traditional hackathon, and you guys won it like as a standout showcase. How was that experience, and why do you think you won? Like, why does it showcase so well the Cartesi potential, right? Cartesi rollups potential, and how does Cartesi enables the application to actually be what it is?
Yeah, so Bugbuster was created in the first edition of the Experiment Week by four incredible people: Eduardo Bartel, which also won the second edition, Francisco de Moura, Gabriel Lineu, and I. And we came up with the idea of a bug bounty platform after realized that we could run arbitrary user-submitted programs in like a sandbox environment inside Cartesi machine. And that's a powerful feature that we don't see being explored very often, right? But is actually what enabled our application, right? And actually, several ideas of applications came from that realization. We also thought of a programming contest platform and advent of code application, but we decided to pursue the bug bounty platform idea because it aims to solve a fundamental problem with existing bug bounty platforms, which is the need for trust, right? And it was much closer to us, this idea, because we had a personal experience with bug bounty platforms in Cartesi. And because of this, we saw Cartesi itself solving the problem. So I think that was a powerful thing that made Bugbuster stand out.
I think it's actually insane that you can on Web3 verify, run Web2 programs, and actually be able to not even just run them in a simple way, but also attest for their security somehow. Can you guys give us a live show, like just to see a sneak peek of what it is, a teeny tiny demo or something?
For sure. Let me see. How can I share my screen? Present.
Yeah, exactly.
Let's do a quick demo of Bugbuster to give a taste on how it works. This demo will base it on a tutorial that we published last month, where we show how to create a bug bounty for a smart contract project in Bugbuster testnet environment, right? This tutorial describes step by step how to prepare the project, all the steps to make it possible. But I will, for keep your call shortened, get some specific steps that I already prepared so we can go faster here. But I really would like to invite people to go there and check this tutorial. I think we can put this link on the description of the video later, right? So let's go. First, what we will do, bug bounty for a smart contract project. Which project? We will do a bounty for a very simple smart contract, a counter one, which has a number variable, set number function, which allows us to set an initial number for this counter, and increment function, which simply adds one to the number. To make things funny and also to allow us to really have the experience of a bug bounty, we will add a vulnerability into this code so we can exploit that and feel the sensation of being a hacker. We will use, put a vulnerability here to introduce arithmetic overflow fragility, right? And by default, the Solidity compiler, it protects against this kind of vulnerability. So we will use this unchecked statement to disable this default protection from the Solidity compiler so we can exploit that. a very important warning here, please never do this on code that is intended to be deployed on mainnet, right? We are doing this here just for educational purpose. So this is the project that we will experiment here. And when creating a bounty, we will submit this code for Bugbuster, but we need another piece to go together in a compressed file that we will submit on Bugbuster, which is, Guilherme mentioned that the assertion script. The assertion script is a script, as the name says, that the project describes how to deploy the contract in this case. This script will guarantee that any code that is submitted by a hacker to try to exploit this project will be also deployed and will be run. And then enter the interesting aspect here that we mentioned. We have to program the assertions that we want to check to verify if our project was hacked or not. In this case, we are doing a very simple verification. We will just check after any exploit code run if the code was able to turn the number to 0 again. If the number was turned to 0 again, it was a valid exploit, so the hacker was successful, right? So we will put these two files in a compressed file, a tar.xz file, and submit it to Bugbuster. So I already prepared this file. We will, for that, access Bugbuster on testnet. The link is preview.bugbuster.app, and we will enter into its landing page. This is the current one, but we are working on a new visual that will come soon, so stay tuned. Here we can enter in explore bounties. So we will have a list of bounties here. Of course, this is testnet, so there is a lot of test bounties here. We will select create a bounty here, and then just fill in a form. So let's name this bounty as I built the 4am bounty. Let's just use the same description here. I have here, we use an image as an icon for the bounty. I have a link for one that I like here. Let me just copy that here. It's optional, but I like to put it. Guarantees a nice visual. Then we have to provide the address for the token that will be used as a reward. Here I'm pasting the address for the USDTC contract on Optimism Sepolia. Bugbuster is on Optimism. So here we are on Optimism Sepolia testnet. We have to define a deadline. Let's say that is tomorrow. And then we have just to drop the compressed file. Here is the file that I already prepared with the contract that I just showed for you, and also the script that tests the result. So we have to click on create, open, MetaMask will open, asking for confirming the transaction. We just click on confirm, and let's wait until the notification arrives. Okay, notification arrived. We can back here. At the end, it will appear here our bug bounty. Again, we are working on new features, so very soon we will have a filter one that we will be able to filter for only open bounties, exploited bounties, expired bounties. We will be able to order this list, so please stay tuned. Let's enter in the just created bounty. It appears here, it will end in 1 day. And then we have here two options. Sponsor one, where you can enter and deposit some reward here, and the submit exploit. The submit exploit procedure is very simple. You just provide a name, Cláudio, and then you can put unscript here. Coming back to the tutorial, I have prepared some tests here. For example, let's use this first piece here, and I will explain what it does. This simple smart contract here just gets the reference to the counter contract that we just deployed on the Bugbuster execution environment. You start setting the number to 1, and then just call increment. Let's see what's the effect here. We can click on test, and then it will do a lot of things in background that I will list here as the log appear here. So here we can see that Bugbuster received the exploit, set up the Forge project, compiled for files and Sol C 0.8.28. The compilation was successful. Started up the ref, which is the EVM that we are using. Waited until the ref started to listen for requests. Okay, ref is okay. Deploy some contracts, and then run the exploit and verify that execution. So this code was not able to exploit our contract. Okay, very simple. We were with an initial value of 1. We just incremented 1 to 2. We didn't reach the maximum value of the type of the variable, which is uint 256. Now let's feel the sensation of hacking it. This code is able to do that, remembering that we introduced by purpose a vulnerability into the counter contract, right? The code is very similar. We just get the reference for the counter contract. And then the first thing is, let's get the current number, and then let's get the offset of the current number to the maximum value of the type unsigned integer 256. Let's set the current number as this offset, and then to provoke the arithmetic overflow, let's increment our counter. Let's click test and see what happens. Remember, this time we are waiting is that Bugbuster is set up in the project, is putting ref, a full EVM to run, and then deploying contracts, executing the contracts, and then voila, the exploit test succeeded as expected. This is just a test, but we can, and it not submit the transaction on chain, but we click here on submit. Now that we know that this code really exploits the bounce, we can submit this code on chain. Just submit, confirming on MetaMask. Okay, I received confirmation from MetaMask, and here we have our bounce. Let's just do a quick refresh, and then our bounce appeared as exploited tag. So we can see very simple, very straightforward. And then since I exploited that, I can come here on list vouchers to see if there is a reward waiting for me. This is the reward. Of course, I didn't deposit any reward here, so I have a voucher of no value. And as Bugbuster is an epoch-specific rollup, it's missing the proof because I sent the valid exploit, the code was confirmed, the voucher was emitted, and then we'll have to wait until the end of the epoch, the finality period, to have a proof and then make it able for me to execute the voucher. So this is the full workflow of creating a bounce and then exploiting and checking the voucher availability.
It's just amazing how smooth it is, how well it runs, and how fast everything happens. Like in your eyes. This is such a great example. There was one thing that I didn't understand quite well. There was an option right there to sponsor the bounty on the interface. What does this sponsoring means exactly?
Yeah, the idea is that when you are creating your bounty, you can deposit some reward, some amount of token. In this case, I created a bounty using USDC token, so I could deposit some amount of USDC token. But as the idea of Bugbuster is collaboration, anyone interested in my project could also deposit some reward there. So we could here create a campaign. So if we find this project useful, please deposit some reward there so we can have it tested by hackers to make it attractive, right? So this is the idea.
I see. Wow, that's just great. Thank you so much for such a complete demo. I think everyone can have a very good idea of the potential of Bugbuster there. I like, how did it evolve from the initial conceptualization, the initial concept, to what we have today, to what you just showed us?
Can you get that, Guilherme?
Yeah, of course. So after Experiment Week, we were left with a huge list of future improvements, as it is common with hackathon projects. And from that list, we did manage to support bounties in any ERC20 token. It used to be only with Ether. And we think that it aligns better with projects that want to use with their tokens, right? And so if Cartesi wants to sponsor their own smart contract bounty, they can use DSI, for example. But we have many other features in our backlog. One of the most exciting ones, in my opinion, is the one that implements a commit review scheme for exploits so that there is no front-running attacks. So that's one that I'm excited about. But I say that the biggest change we made since the first Experiment Week was to improve the support for smart contract bounties, which are so important to ensure that Web3 is safe for users. And which changed this, we made this shift very recently, and we realized that we should focus more on Web3 smart contract bounties. But it still supports any Web2 programs just as well.
Yeah, I remember. I think in the first presentation you did a REST example, right? Exploit example or something. So that's very cool. But it's very nice that you went meta using Web3 to protect Web3.
Yeah.
You also, yeah. Go on. Sorry.
There is even the possibility of using Cartesi to test Cartesi, right? So I have a bounty for the smart contracts that power Cartesi rollups, all of this running in Cartesi rollups.
So you can run a Cartesi machine inside the Cartesi machine to test it.
Also possible, would be with some performance penalty, of course, because there will be triple emulation, but it's feasible.
Out of this world, man. You also had the opportunity to show a demo somewhat like this, I think, at Super Demo Day, right?
Yeah.
Want to take this one, Cláudio?
Yeah. Well, it was a nice experience because we had just launched Bugbuster on mainnet, and we have this opportunity to present Bugbuster on the Optimism Superchain Demo Day together with other two projects. And it was nice because it was an opportunity to structure the idea, present to a wider audience, and also to receive feedback. The host of the call was Jesse Rock, was a very generous guy, made interesting questions, and it was very exciting because, well, when we are presenting something, it's very motivating when people ask us questions that we feel that they are trying to understand, that the idea had some catch on them, right? And so we got very excited about that. And it was also important to make Bugbuster spread a little bit. We after the call, we had some pump in our page views. People got interested in checking our GitHub repository. We checked that some stars appeared, so it was a nice opportunity.
This is awesome, man. This is amazing, and like this exposure is so good for you guys, because I think people still have to understand better how much benefit you bring to the ecosystem as a whole. Like it's not just Cartesi, it's all Web3.
I'm suspect to say, but for example, on this demo, I sometimes I present this demo and people take some time to understand that, wait, you are running the EVM inside an out VM? Is that what I saw? Yeah, that was the thing. And you see, it was very quick, very fast, right?
Yeah.
We execute the ref from scratch every time a bounty is submitted, and it was very fast to spin up the EVM node, to deploy the contract, to run the exploit, and to check the results. So it's something that this is just the tip of the iceberg, right? I think we will be able to bring much more interesting things for this project, and something that is very interesting. I don't know about other projects, other bug bounty platform that is based on Web3 tech, right? They are typically centralized, or they rely on some kind of economic model, but the tech, differently from Bugbuster, is not built on top of Web3 technology, right? So Web3 protecting the Web3.
Love it. Just to get a better understanding of like how you were able to pull it off, create all of this, could you give us like a whiteboard session, show us a little bit of how the magic runs in the background?
Yeah, sure. Let me share my screen. Let me create a whiteboard. Can you see my screen?
Yeah.
All right. So let's start with some rectangles. Everything starts with some rectangles. So this is the Ethereum rectangle. Let's increase that font size. Let's put it up there. All right. So that's our left rectangle. And we'll have a right leg. That duplicates.
Works. Yeah, there you go.
Oh, there you go. Duplicate, right? And here we have the Cartesi machine, right? So on the left, you will see an architecture that is common to most Cartesi applications. So we have the input box contract, which receives the inputs, right? We're using Ethereum call data as data availability. And we'll have the application contract and the ERC20 portal contract. So the user, through the web interface, will use the input box to create bounties, to send exploits, and when it involves currency, right? So ERC20 tokens in this case, in order to sponsor applications, it's going to use the ERC20 portal to talk to the input box contract. And the application contract is used for voucher execution. So when you exploit a bounty and you want to execute that ERC20 transfer voucher, you're going to be calling the application contract. You provide a proof, and it's going to execute the transfer function. Also, when you sponsor and the bounty expires, right? The bounties have an expiry date. Otherwise, If you have a perfect software that doesn't have an exploit, your money will be locked there forever. So we decided to add this expiry date to avoid these cases. So when that happens, you can also get reimbursed. So those are the contracts. And inside the Cartesi machine, we have a very special piece of software that I mentioned before, which is the sandbox, right? The sandbox is used to isolate the user-submitted program from the rest of the machine. Without a sandbox, we could run into serious trouble, right? Users could submit malicious code that could take over the machine, could make the machine run forever without exiting. So in order to prevent this, we have a sandbox in place to block dangerous Linux syscalls. It restricts CPU usage, CPU time, and memory usage, and some other stuff, but mainly to restrict access to the outside world, right? And you have some other common boxes you would see in Cartesi applications. We have the HTTP, the rollup HTTP server, right? Oops, server. Oh boy. And you also have the backend, right? So the backend is written in Go. It uses a high-level framework called, it used to be Agro, but now it's Romolet. Let's see the wordplay. So I think those are the main components, if I'm not mistaken. There's also, oh, I forgot. There is also a bunch of programs and libraries that live inside Cartesi machine because it would be too expensive to add them through inputs. So we have built-ins. And here I'm going to mention some examples. So we've seen that Ref is inside the machine, right? It's a production level Ethereum execution client. It's not small. If you were to add this through inputs, it would cost a lot of gas. We also have the Solidity compiler. We have also some other examples like the Lua interpreter. Of course, we have the Foundry toolkit, also for interacting, deploying smart contracts. And not just programs, we also have, let me remove Lua here, we have OpenZapling, right? So many contracts use OpenZapling as a smart contract library. And recognizing that, we decided to also put OpenZapling there in order to reduce the input size. So you can assume that this is inside the machine, and this will reduce your bounty bundle size. And that's, I think, a summary of what's behind the scenes.
This is amazing. And just one more question, like in front of the scenes, there is some magic happening in the front end as well, right? You run I think I read somewhere, you run a Cartesi machine on the front end first to simulate the bounty happening, and then you just submit if there's an exploit or something. Isn't it?
That's on our to-do list. We really want to do that. We know it's feasible, right? Joao has written amazing documentation on how that's feasible. You compile the Cartesi machine to run with WebAssembly, and we've seen amazing applications, including the dev advocacy unit, use that feature to power great applications. And we really want to do this as well, because then you wouldn't depend on the node to run for you through inspect requests, which is how we're doing today. But we do want to do this in the future for sure. Yeah.
This will be insane when it's there.
For sure.
What are some of the technical decisions, relevant things that you have to make to reach the state where you're at right now?
So one of the first things we realized early on is that we'll be needing a sandbox environment, right? So for security reasons, and that's for all the reasons I mentioned, right? So blockchain is a very hostile adversary environment. It's permissionless, right? So anyone can send anything to the machine. So we had to use that to restrict access to, the rollups, HTTP API, etc. We also decided to embed all of those applications because of size reasons, right? And also convenience reasons, right? Because otherwise you'd have to pack the whole Foundry library and the REF application, and this would take a load on the users as well. So I think those are the two main technical decisions we made that were crucial to make it a feasible project. Yeah.
And what about challenges? Were there anything that stopped your way, or was a very big stone in the road?
Well, we did feel some resistance from developers that were not very familiar with Web3. Now, I do have to mention that Bugbuster is not exclusive to Web3 applications, although we're now focusing on smart contracts. You can very much run Web2 applications, right? We have examples for Lua Interpreter, the SQLite database, BusyBox toolchain that's very much used in Linux applications. But we do reckon that adoption by users outside the Web3 community is still a problem for the industry as a whole. And that's one of the reasons why we decided to focus on smart contract bounties, not only from a UX perspective, right? Because people that develop and hack smart contracts probably know how to use MetaMask and other tools. But we also see from a philosophical side, we think that they align more with the Web3 ethos, and therefore give more value to applications that value trustlessness, decentralization, censorship resistance, and all of that Web3 ethos. So I think that's one of the challenges that we and other applications face.
Yeah, and there is also the common issue that any blockchain project face, which is to create community, to really bring adapt to live. For example, until now, we are, as the industry, trying to bring really useful and the apps that matter for people, for the society. And Bugbuster focus on a niche inside the niche, right? Because we focus on security. Our target audience are hackers, are people building a specific building project and trying to bring security. So I think in this case we share this common issue of how hard it is to create a community, to make the word of your product to reach the more people that can be interested and can benefit from your product, right?
Yeah, it's always hard, this community building part, because it's not only about reaching out to people and making them interested, but it's always going back to them and making them wanting to come back to you. It's a double-way effort that it's really nice to see when someone is able to pull it off.
Exactly, and also there is this economic attention war, right? There is a kind of a war for attention. So there are a lot of projects every day pumping up and trying to bring people's attention, and so you have to appear inside this multitude of projects and shine some way to touch people that could benefit from the idea. So it's huge, man.
It is crazy. And talking about like general context of Web3, I always love to put some of these general context questions in our rapid fire round, which is a round where I make some quick questions and you answer what's on the top of your head with small sentences, just small words. So let's try it here with you two. All right.
Let's go.
When was the last time you felt like pulling your hair while coding?
I would just say that smart contract debugging wasn't always so easy. I remember like trying to debug with hard hats, and it's not fun. It's painful. And Foundry has really helped in that developer experience. Yeah.
Couldn't agree more.
Yeah, I don't remember. There is so much time because I'm more than 20 years working as a manager, as a coordinator, and for the good sake of the project, I try to keep out of the critical path, just getting some small things, doing some spy experimentations, but not in the critical path which is where this kind of thing really happens, right? Because you have the pressure of time, the expectation of people waiting for your delivery. So
Exactly. What about bugs? Which bug do you hate the most? As in the insect bug.
The insect. As a Brazilian, and I think not only Brazilians, but like anyone that lives in a tropical region will agree with me, there's no discussion. Mosquitoes are the worst. I don't know why God invented it, but I think they shouldn't exist.
well, I would not sleep very relaxed in the same room with a spider.
Yeah, that's fair. That's fair. I saw. I really agree with Guy. Like one of the biggest advantages of moving away from Brazil is not having mosquitoes on me all the time. But also with Cláudio, spiders scare me, and if they're big, they scare me a lot.
Exactly.
But now for a more serious one, what are your favorite protocols or people to follow in this space? Besides Cartesi.
Besides Cartesi,
Yeah.
of course.
I love to
Everyone follows and knows Cartesi.
Yeah, I love to follow the L2Bit guys. I learn a lot about what is really important for blockchain to get into a very serious industry. I also like to follow the Rollup podcast. I think those guys do an amazing job bringing very valuable content. And recently, I discovered that two girls from Espresso started a podcast that seems to be very, very, very nice, and I put on my to-do to start listening and check.
It's a really nice podcast from them.
I think it's composable.
Yeah, exactly.
Composable. Nice. I'd say Risk Zero. We have a strong partnership with them. We might use their software for Dave, which I'm really excited. I'd say Eigenlayer and Espresso. We've also had great partnership with them, and they are posting really amazing stuff as well. So I'd follow them as well.
Talking about our partnerships, we just had a hackathon with Eigenlayer, the Experiment Week. Who on Web3 would you like to work with on a hackathon?
I remember there was one participant from the DEF CON hackathon, which really stood out for me. I think he's the creator of the Hard Hat Deploy plugin. We use it for Rollups contracts. I think his name is Wigawag on GitHub, or Ronan in real life. He made like an amazing project, like a 3D football, right? And anything football surprises the Brazilians, right? So it surprised me.
He made it look simple.
Yeah.
Yeah,
well,
I don't know how he made it.
In my case, everyone in Cartesi is such great and skilled professionals, so I would be very well accompanied with any of them. I'd like to repeat the experience with Bruno Menezes, Shaheen, Cynthia. That was amazing when we worked together in the second edition of the Experiment Week.
Yeah, and you got the prize.
Exactly. It was amazing.
Now, about exploits. Can you hack the honeypot?
I'm
I
definitely not.
could. We and nobody has yet. So I'm pretty
I
confident I can't.
like when after Eduardo tried and he didn't succeed, I was like, yeah, probably I won't succeed as
Yeah,
well.
it's a hard problem, bro. Eduardo was not able to do it.
Now, fun question. How many bugs does an average human unknowingly eat in their lifetime? Try to estimate.
Oh no.
I have no idea. This is
I hope none. I don't know, 3 at least in their lifetime. How do you have the number in you?
well.
I think I ate more than 3 bugs at this point.
I don't remember well my childhood. Maybe I ate some.
Okay, guys, this is really fun. But going back to the more serious questions, like, how do you feel Bugbuster positions in educational value, like helping people to learn security practices on Solidity in general?
Yeah, this was a nice surprise that recently, especially after the tutorials that we published on how to create bug bounty for smart contract, that people learn Solidity and learn security practice for smart contracts started to reach out. Some enter our Telegram community. Others forked our project, directed message us, and we saw that trying to understand this movement, that they find useful to have a platform that easy to just put your code there and share and ask people to take a look and see if they are able to exploit it or not, in a kind of collaborative learning model, right? You put there, if no one is able to hack it, you are doing a good job. If someone is able to hack it, you can learn what are the fragilities there. And so this was a nice experience. And we also had the experience of some guys that were working on a project involving machine learning and natural language processing in the seed grants of Cartesi, that they forked Bugbuster and adapted it to become like a Kaggle, that very well-known platform for machine learning, where you and create a kind of contest that people submit some models for a problem, and these models were run inside the Bugbuster. They were scored and ranked, and after some period they were classified and then announced the first place, second place, and etc. And then we are seeing this movement that we're not expecting, but we are very excited to get into it and see what we can do in the platform to make it more valuable for these people. To maybe this is some niche that resonates more with the idea of Bugbuster.
It's beautiful, right? This open source ethos allowing us to share content, share knowledge as a whole. It's something that Cartesi follows. It's something that Bugbuster follows. So it's really nice to see it happening. It's amazing.
Yeah, we are seeing good reactions on that direction of smart contracts. So we want to invest more energy on that.
And it must feel like a huge win when your project is forked and someone starts building something on top of it.
Yeah. This is very, very nice.
Guys, this was amazing. I'm going to have to wrap up, but thank you so much for coming. This was such a nice discussion. Always like talking to you guys. Love talking to you guys. So that's it. If you got any last words.
Oh yeah, would you like first to thank for the invite, and also invite people to take a look at the tutorials, to try try for their project, try for the projects that they got interesting, and talk to us. We are eager to talk.
Perfect.
Yeah, thanks for having us. Follow us on Twitter. We have a Discord channel. How do I say, like a topic that's very, very hot. We always post like the latest update there. So if you want to keep like on the edge of announcements, that's where we post first. And we have a Telegram as well if you want, if you use Telegram. So yeah, thanks.
Yeah.
That's awesome.
Bye-bye,
Make
guys.
sure to follow, and that's it. Keep building and pioneering the world of Web3. Bye-bye, guys.
Bye-bye.
Bye bye.